Okay, so we're starting 9.2, systems of linear equations in two variables. I guess not. We will discuss applications, and I think after the applications, we will talk about a system of equations in three variables. So the next section.
This is substitution and elimination. As you all know, there are two cases. I don't think I should even do these two cases because you could review on the previous classes. You know, the two lines intersect. If you graph two lines, what are the possibilities? So if you graph two lines, there are the three possibilities, right? Let me start then. All right. So, oh, did I share my desktop? No, I didn't. Oh, okay. Let me do it. Let me share my desktop. All right. So, okay. Good. Up to 60 in the new section. 9.2. A system of linear equation in two variables. So, example of the system is, for example, really quick. So, number one, this is, I'm going to write this as case 1, and I'm going to do it really quick. So, suppose I have 3x minus y is equal to 0, and 5x plus 2y is equal to 22. Now, if we solve this, if we graph this, this is a line, and this is another line, right? Line 1 and line 2. Now, based on these, there are three cases. In this case, I'm not going to solve it, and I'm not going to graph it, is we have the lines that are intersect. Yeah? So, is there a solution? So, when the lines intersect, what happens? How many solutions do we have? Yes. So if your case 1 is when the lines intersect, you have one solution. Where is the solution? Yeah, where the line meets. And we say that the system is consistent. What do I mean by consistent? It means it has at least one solution. Oh, by the way, today there is a ribbon cutting ceremony for this building. So you get free food. It's at 10:30 outside. Do you see the balloons? They started to put the balloons. Yes, so it's at 10:30. You guys are invited, and there is food. I don't know how good the food is, but there is food. Yeah. And the next one is the equations are independent. So you have two equations. And how many lines do I have? 2. So they are called independent. Why? Because two equations represent two distinct mean two different lines. All right. So this is case 1. So case 1 is when the lines intersect. So when you graph these, you'll know. Yeah. Now, we're not going to solve it. Now, the second one is case 2. So, to give you an example, if I have 2x minus y is equal to 7, and 2x minus y is equal to 10, all right. So this is an example of case 2. So when you graph, this is also a line. Each of them are a line. What do you see about these two lines? They have the same slope, yes. So this is your line 1, this is your line 2. What happens to line 1 and line 2? They have the same slope, so same slope in this case. So what do I mean? What happens if they have the same slope? They're parallel, yes. Right? So this is case 2. So case 2 looks like this. These two lines are parallel. So lines are parallel. And then there is no solution. So if there is no solution, the system is inconsistent. Right? So why is it inconsistent? Because there is no solution. Yeah. We say that 2x minus y is equal to 7. How come on another one, we say 2x minus y equals to 10? That's not consistent. How about the equations? Are they dependent or independent? Yes, are independent. Why? Because two equations represent two different lines. So it is possible that a system has no solution. Yeah, it is possible. All right. What is the other possibility?
That they run on top of each other.
Yes, they're on top of each other. Yeah. Okay, let me see. Are you done? No? So the next one, case 3. Finish? Yeah, okay. So next one is case 3. This is the third one. So suppose you have, let's just say, 5x minus 3y is equal to 15. And then 10x, negative 10x plus 6y is equal to negative 30. All right. So what do you see about the first equation and the second equation? What do you see about those? Equation 2 is what? Is negative 2 times equation 1. Right? Are they equivalent? Yes. So when you graph the line, what happens? They are on top of each other. So these two lines intersect. Line 1 and line 2 intersect. Not intersect. What do we call it? Overlap. So the lines overlap. Or in math, they say the lines coincide. Right? And then how many solutions? Infinitely many solutions. What are the solutions? What are the solutions? No, it's all ordered pair on the line. All ordered pairs on the line. Right? So if I choose this point, this is not a solution. Where are the solutions? Every point on the line. Right? Okay. So is the system consistent or inconsistent? Yeah, the system is consistent. Why? Because it has at least one solution. because it has at least one solution. Now, are the equations dependent or independent? Are dependent? Yes. How many equations we have? 2. So 2 equations represent one line. So dependent. Okay. So those are the 3. So it is possible that you have one solution, no solution, and infinitely many solutions. Those are possible. So now I'm going to talk about the word problems. Yeah. So B. Oh, did I label A? No? No. Oh, okay. So can I go back and label A? So A is type of solution. Okay. So this is what I wrote for A. A was type of solutions, and B, so A is types of solutions, and then B, modeling applications. Let's just say applications. So what do we do in applications? So what we want to do in step 1, steps to solve. So we identify the variable. All right, so this is step 1. And then we also represent the unknown in terms of the variable. Now, step 2, we create a table or diagram if necessary, only if necessary. Step 3, we write the equations, the system of equations. So step 4, we solve. And then step 5, write a phrase to interpret result. And then we want to make sure to use the proper unit. All right. Okay, good. So let's do yes. All right. So let's talk about speed. Yeah. When you guys are ready, then I'm going to write the problem. So we always use this in my Math 115, 125, Math 260, it's the same thing. Yeah. Okay. Are you guys ready? Yeah. Okay, so let's start. Oh, that is it. Okay, good. So next example. This is a speed problem. This is page 650 number 47. So a man flies a small airplane from Fargo to Bismarck, so both in North Dakota. A distance of 180 miles. Okay. Because he is flying into a headwind, this is into a headwind, the trip takes him 2 hours. On the way back, the wind is still blowing at the same speed. Alright, so the return trip takes only 1 hour, 12 minutes. Alright. What is the speed in still air? And what is, and how fast, and how fast is the wind blowing? So 2 questions. All right. So what would you do? So we don't know 2 things, which is what? What is the plane speed in still air? Yeah. And also wind. So one should be one variable, the other one should be the other variable. So what do you want to use for the 2 variables? X, Y? Okay, good. So X is which one? The speed of the plane, or you could use A, actually, A and W. Should we use A and W? Okay. So A is the speed of the plane in still air, right? And then W, what is W? The speed of the wind. Okay, do you think we have a table? Yes, it would help. So how would the table look like? Well, what formula do you think we're going to use? Distance equals rate times time. Yes, so distance is equal to rate times time. Yes. Distance equals to rate times time. You remember the formula, don't you? B is equal to R times T. Alright, so that is your step 2. Now, what category should I put on my 2 rows? Headwind, and the other one is tailwind, or going forward, and the other one is going back. Yes. So going forward and going back. Yeah. What is the distance? Do we know?
180.
For which one? Both? So 180 each? Okay. Good. Do I know the rate?
No.
No, but we call it A and W, right? So what am I supposed to put here? Well, what is the speed? When it is headwind, what does it mean headwind? Is the wind against you or slows you down? So this is A minus 2? Oh, yeah. A minus W. What about if it is tailwind? A plus W. Good. Now, do we know the time? Yes, which is what? For the headwind, it is 2 hours. So are we changing everything into hours? Or do you want to change it to minutes? So the speed is usually miles per hour, right? It's not miles per minute. So we need to change it to hour. So 2 hours. What about 1 hour, 12 minutes? So this is 1 hour, and then what? 12 over 60. So how many hours? 1.2 hours? Yes. So this is 1.2. Because the speed is not miles per minute, it is miles per hour. Yes. So do you think you have two equations? Okay, do you think you can solve it? So what are my two equations? So yes, 2 times A minus W is equal to 180. Good. So A minus W is equal to 90. So this is equation 1. So divide both sides by 2, right? What is the other equation? 1.2 times A plus W is equal to 180. Can I divide by 1.2 both sides or no? What is 180 divided by 1.2? 150? Yeah, so can we divide by 1.2? Yes. Yes. A plus W is equal to 150. This is equation 2. Right? So you have two equations. Do you think you can solve it? That's easy. So this is your step 3. Now, how do you solve it? Elimination? Yes. So we eliminate W, right? So if I add these, what do I have? 2A is 270. A is 134. What is W? Wait, is that right? Yes, it is. What is W? 45, yes.
Oh, no, it's 240.
90 plus 150 is
240.
240, yeah. So you have 90 plus 150.
Yeah.
So it's 240. Yes, it's 240. So 120, right? So what is W? 60? Oh, no. 30. Yes, 30. All right. Good. So what is your conclusion on your step 5? The airplane, what is the unit? 120 miles per hour, right? What about the wind? 30 miles per hour. So the airplane is not too fast, right? Usually, what is the speed of airplane? What is the speed of airplane usually? Right. If you fly, for example, transatlantic, meaning transatlantic, trans-Pacific, you go to Europe or you go to Asia, usually the speed is around minimum 500, 600 miles per hour. Yeah, that's like the minimum. Yeah. Yeah, if jet, how, turbojet, how, like maybe 700, 800? Is it? About 300? No. Oh, Mark 3. Yeah. G6? I mean, anyway. Yeah, this one is I think this one is with the propeller, right? Yeah. Yeah, and it's only 180 miles. If you go 600 miles per hour, then maybe only, well, you have to take off and land, right? Yeah. So, anyway, is it possible? Do you still remember this? Distance equal rate times time? Yeah? Okay. The other one is mixture. Should we do mixture problem? Yes? One more? Okay. So this is motion problem. So let's write these. This is a motion problem. So B1, applications involving motion. And then the other one is mixture. All right. So the next example, oh, I'm supposed to write it here, right? On the example here. So I'm supposed to write it before that. Yeah. B2, applications involving mixture, and then we will move on to the next section. Yeah. So B2. By the way, when Dr. K is here, can you guys please be kind to him? Well, I mean, you are always kind, but just be extra nice to him, okay? He's my department chair. Yeah. Just be extra nice. But, you know, my husband was here and he was looking at you and then he was impressed. He usually deals with the MBA students because he teaches MBA. And he said that you guys were very good, very attentive. So he was happy. And I asked him, why don't you just teach at ELAC? Yeah, he said he would if they have opening. He teaches business, accounting, finance. So if they have a full-time opening, he will apply. Because he saw you. He saw how good of students you are. Yeah. Anyway, B2. Applications involving mixture. So if later on there is a full-time opening, I'm going to ask him to apply. So he could just teach here. Yeah. That way it's easier. You know why I don't like him to teach at the school? Because our holidays are different. They use trimester. Yeah. So so the holidays, like our spring break, are totally different. Our summer, well, I think winter we overlap a little bit. Summer we overlap 2 to 3 weeks, but no more. Yeah. I told him I want to go on vacation. So he said he would consider. Because you know why? Because of you. Because you guys were such good students. Yes, that is true. And then yesterday he came also and then watched the Math 115 and Math 125, the later classes.
So how about a full letter grade extra for the whole class?
Okay. Well, I never give you hard tests, do I? And I always prepare you with my sample test, but you have to put in a little bit of effort, don't you think? Yeah. Okay, so let's talk about the mixture problem. Are you mixing coffee or you want to be a chemist who makes sulfuric acid? Coffee better? Okay, all right. So, customer, so this is customer in a coffee shop. Oh, my battery. You know, I really like you guys to all pass with good grades. Okay. So a customer in a coffee shop purchases a blend of 2 coffees. Okay. So the first one is Kenyan. Oh, this is number 52. I'm sorry. Let's see, what page is it? The same page, 650. So page 650, number 52. So later on, you can look at it. Kenyan costing $3.50 a pound. And Sri Lankan costing $5.60 a pound. He buys 3 pounds of the blend. Okay, which cost him $11.55. So the question is, how many pounds of each kind went into the mixture? So how would you solve this problem? Can we identify the variables? What are they? Oh, K and S? Yes. K is the amount of Kenyan coffee. And then what is S? The amount of Sri Lankan coffee. All right. Do we need a table? Yes, this one we need a table. And same thing, you will have 3 columns. Because the last one is a mixture. So then you can have Kenyan, Sri Lankan, and the last one is the mixture. And you have the amount. So what's important here is it's talking about the amount. Okay, what's the next thing that they have here? Price per pound. And then the last one is price. Right? Price, not per pound, but price total. All right. So for Kenyan, what do we use? Amount is so for mixture, you always have 3 columns. For distance, rate, and time, you also have 3 columns. So for the amount, what do we use? Do we know the Kenyan? Yeah, but we call it K. This is S. Do I know the mixture? Do you know the mixture, how many pounds? So here. Yes. So I always highlight the numbers. In math, when you see numbers, you're happy, right? Because that's your equation or that's your coefficient or whatever. So do I know the mixture? It is what? 3. Okay. Do I know the price per pound for Kenyan? Yes, it is $3.50. So 3.5, 5.6. Do I know the mixture? Oh, we don't know. Do we? No, we don't know the price. Yes. And do we know total price? Yes, for Kenyan, I know it's, well, if it is 1 pound, then he's going to pay $3.5. If it is 2 pounds, then it's going to be $7. So this is K pound, that will be 3.5 times K. And this will be 5.6 S. And this will be, what is the price of, the total price of the mixture? 11.55. All right. This is 5.6 S, not 5. This is 5.6 S. This letter here is S, letter S. Now, do we have the equations? So let's write down the 2 equations. What are they? K plus S is equal to 3. And the second one? 3.5K plus 5.6S is 11.55. All right. So you have 2 equations. Do we have to solve it? Or do you think you can do it? Can't you do it? So by substitution, right? Or elimination. Solve, I use substitution. K in equation 1. So K is 3 minus S. This is equation 3. So substitute K is 3 minus S to equation 2. So when you substitute, we have 3.5 times 3 minus S plus 5.6S is 11.55. So 3.5 times 3 is 10.5 minus 3.5S plus 5.6S is 11.55. What's this? 10.5 plus, is it 3.1 S? 11.55? Huh? Which one? What is 2.1? Oh, 3. Oh yeah, 2.1. Yeah, thank you. That's right. So 2.1 S is equal to, is it? Okay. So what is S? 0.5. All right. Ooh, Sri Lankan is only a little bit. Yes. How about the Kenyan? So substitute S is equal to 0.5 to equation 3. So when we substitute, we have Kenyan is 3 minus 0.5, so K is 2.5. Good. What is that price? Sri Lankan, 0.5 pounds. Kenyan, 2.5. Right? So we just use substitution. Okay. Doable? This is review, isn't it? Yeah, because I discussed this in my Math 115 class also. Mixture problem. We were mixing nuts, I guess. And then mixing the coolant, the alcohol. Yeah? In the coolant. Now, what else I remember? Now, I'm done with the applications. Okay? So, let's see. So, let's start 9.3 now. Yeah? This is not hard. So, I'm going to start 9.3 now. Done with 9.2. So, what is 9.3? 9.3 is 3 by 3 system. Yeah? So, we will do 2 examples and then we will be done. Now, Dr. K will start with 9.4. Yeah? So, 9.4, okay. Yes, so let's do 9.3. All right. So let's save this. 9.2. All right. Now, let me close this a little bit, and we say we're done with 9.2 systems of linear equations in 2 variables. So we will start with the next one, which is system of linear equations in several variables. It's a 3 by 3, yeah? 3 variables, basically. All right, so let's start. All right. So 9.3 is systems of linear equations, or LE. I'm going to write LE. LE in several variables. Okay. Oh, that's nice. Okay. So, let's see, for example, so we're just going to solve. So basically, let me write down the goal first. The goal is to get a 2 by 2 system. So when I mean 2 by 2, what do I mean? 2 equations in 2 variables. So that's what we need. Okay. All right. So for example, then you should do something so that you have a 2 by 2 system. Yeah. And how do we get there? Eliminate one variable from 2 different pairs of equations by, maybe I should say, by eliminating one variable from 2 different equations, if necessary. Sometimes you only need to do it once, but sometimes we need to do it twice. So eliminating one variable from 2 different equations. From 2 pairs. 2 different pairs of equations, my God. 2 different pairs of equations. Not from 2 equations, but from 2 different pairs of equations. All right. Okay. So, for example, solve x minus 2y minus z is equal to 1. Negative x plus 3y plus 3z is equal to 4. 2x minus 3y plus z is equal to 10. So this is equation 1, equation 2, equation 3. Let me check. Yeah, yes. Okay, so what would you do here? Let's look at the equations. Do you think you will eliminate x or y?
I mean,
X from which equation? Equation 2. Well, you have to eliminate one variable. So which one do you choose? Equation. Eliminate what? Okay. Eliminate z. Okay. You can do eliminate x or eliminate y or eliminate z. It doesn't matter. Z from which one? Okay. So equation 1 we will just copy. And equation 3, what do? We just copy both? Yes. So x minus 2y minus z is 1. Can I choose to eliminate x? Yep. Can I choose to eliminate y? Yes. Okay. So 2x minus 3y plus z is equal to 10. Alright. So what do we have? 3x minus 5y is equal to 11. So we will call this equation 4. So remember to label each equation, because otherwise it will be confusing. What next? Do I have a 2 by 2? So remember, your goal is to have a 2 by 2 system. Do I have a 2 by 2 yet? No, so I need another one. I need another one in x and y, right? So my first one has x and y. Do I need another one in x and y? Yeah, so how do I get another one with only x and y? So you have to eliminate z again, don't you? Okay, so this time which equation do you choose? 1 and 2, okay. So this is what I mean by eliminating one variable from two different pairs. So you eliminate one variable from the first pair and you do the same thing to the second pair. So equation 1, what do we do to it? Multiply by 3. 3x minus 6y minus 3z is equal to 3. How about equation 2? Just copy. Negative x plus 3y plus 3z is... Alright, so what is this? 2x plus, no, minus 3y equals 7. And this is equation 5. So we're labeling my equations. We're labeling our equations. Do I have a 2 by 2 now? Oh, by the way, do you know why when I label I have to put dot, dot, dot? How come I don't just do this? Yeah, that's right. So if I just do this, see what happens? When I label this is like 7 times 5. So that's why when we label, we always put dot, dot, dot. Which one? Where is equation 5 though?
3x minus 6y minus 3z equals 3.
No. That is, we don't label this. This is equation 1. We multiply by 3. So what we do is we take equation 1, we multiply by 3. And we don't label it because we don't use it. We only label the ones we use. Yeah. Okay. Now, if I have a 2 by 2, do I know what to do? What do we do? Yes, so eliminate x or y? X from 4 and 5. So what do we do to equation 4? We multiply by 2, right? So 6x minus 10y is 22. Now what do we do to equation 5? By negative 3. Yes, you're right. Negative 6x plus 9y is negative 21. All right. So negative y is 1, is it? Y is negative 1. Y is negative 1. How do we solve for x? Yes. So substitute y equals 1 to which equation? Yeah, 4 or 5, right? I just choose 5. Why? Because the coefficients are smaller. But of course, there's no problem when choosing 4 or 5. So 2x minus 3 times negative 1 is equal to 7. 2x plus 3 is 7. 2x is 4. What is x? 2. Yes. Good. Now, last one, z. Yes. So substitute y equals negative 1 and x equals to 2 to equation. Which one do you like? Yeah. I like 3. So I do 3. Yeah. But you could do 1, right? Same thing. The answer is the same thing. 2 times 2 minus 3 times negative 1 plus z is 10. So what's this? 4 plus 3? 7 plus z is 10. So z is 3. Yeah. So even if you substitute to equation 1 or 2, we still have the same answer. So let's write down the order triple. 2, negative 1, 3. So this is my solution. Okay. Is it doable? Yeah. Easy? Okay. So do you think it's okay to do one example only? Yeah. So let me see. Should we do system with infinitely many solutions? Yes or no? Or you guys are okay? You're okay? Doable? So basically, your goal is to have a 2 by 2, yeah? All right. Now, why don't we do this? So Monday till Thursday, Dr. Casimir will be here, right? I don't know what homework is due or what he finishes on Monday and Tuesday, so I'm going to keep the homework open until Sunday. Yeah, so I think on Thursday, Dr. K will email me, Dr. Casimir will email me, thank you, which one, and then I will close whatever homework it is on Sunday. Is that okay? So Wednesday, there's nothing due, but should I put 9.2 on Sunday and 9.3? Do you think you could finish by Sunday? Or you want, so 9.2, 9.3 on Sunday? Okay. Okay, sounds good. Okay, guys, I will see you in a week, I guess, right? Not this Monday, but the following Monday. But Dr. K will be here. Okay? Yeah. Yeah, just be really nice to him. Okay. Yes. Yes, I see.
They're two separate forms.
Oh, okay.
They both need the same information, but they're two separate forms.
Yeah, maybe you put your name and student ID, and let me get my pen while I'm getting my pen. Okay, guys, you have a good weekend. Yeah, and I'll bring you some pictures from Philadelphia and Boston. No, it's not vacation. No, Philadelphia is conference, the SPAM conference. Yeah, no, it's not vacation. The vacation is only on Thursday. Yeah, but Monday to Wednesday, not vacation. Yeah. Otherwise, how can I take a week vacation? I mean, that's not good. Yeah. That's fine. Only on Tuesdays. You don't worry about it. Yeah. But he's not going to record the lecture, so make sure to get the link from somebody else. Yeah? Okay. Okay, thank you, Alex. Okay, let me close this, and then I'll... Okay, so we're done with system of linear equations in several variables. And on Monday, Dr. K will be here. All right.